In the previous video, we made the hypothesis that merge sort should take log base 2 of n times as long as the corresponding radix sort on an input of the same length where all the strings are equal. So what we're going to do in this video is put that hypothesis to the test by doing a careful empirical study. And I think you'll find the results pretty interesting. So what I'm going to do here is my computational experiment is going to fix W equal to 100. And then we're going to call merge sort for n equals 10,000, 100,000, million, and 10 million. And we'll do the same thing for MST sort and just see how they compare. Okay. So what I've done to make this experiment possible is I've set up a bunch of code that you can get from the lecture code repository. So in timingtest.java, you first pick the sort you want to use. And your choices are merge sort, MST sort, and LST sort. I'll pick merge sort. And then we will also pick what conditions we want to be true about our strings. So the choices are equal, almost equal, where they're equal up to some character, same reference, and that means that every string variable in the string array literally points to the same object. And then I have random. Okay? So I'm going to use equal here. And now, when I run my code, I'm going to be merge sorting between 10,000 and 1 million strings. Count those. Sorry, 10 million strings, where each string is of length 100. Okay. So here, when I run this code, what happens is, for 10,000 strings of length 100, it took 0.02 seconds, and we had to consider a total of 13,801,600 characters. And running that for all of my different n's, we see that, no surprise, as n grows larger, the number of so the total runtime increases, and so too does the number of characters considered. If I change this to MST sort and run it, now I'll get some other runtimes. Okay, so 100,000, it took 2.52 seconds, and so forth. And so I'm not going to let this run all the way. It's going to take quite a long time, and I'll just show you the table. So here, when I ran the experiment earlier, my runtimes for merge sort were as shown here, and for MST sort as shown here. Now, as we expected, merge sort is taking log base 2 of n times as many characters as MST sort, right? So for example, log base 2 of 10 million is 23.25 or so. And indeed, the number of characters that we examined running the code was around 23 times as many. Now, the question I have for you is, does this data match our runtime hypothesis? No, right? We said merge sort was going to be slower, but actually, if we look here, it's considerably faster. So why not? That's a question you can ponder. And then in the next video, I'll give you an interesting answer. So try and think, why might this be? Why was my analysis wrong? What are some possible reasons?